Hello there, this is Alan, and this would be lesson 38 in this tutorial series. What you're looking at here is a link to a little utility that I made for making copies of projects. I'm about to use that utility and show you how it works. If you want, you can download this and use it for yourself. Now this project here I'm going to use as a template, basic console program. I'd like to make a new project for this lesson. And the way it works, if you've installed that thing, to send it into the copy project link, type in the name of a new project, CPP intro, because this time we're going to talk about CPP, C++, and it makes a new project here. The reason why I've made a program to do this step rather than just using copy and paste and some renaming is for this reason. Each of these projects has a unique identifier. So simply copying and pasting a project and then renaming the project name doesn't change this identifier. So that project is still going to be identified as being the same. So one of the reasons is to give each project a unique identifier. I don't know if you remember what that last one said, but this is different, it turns out, than the last one. The other thing is source control, which I'm using, and you probably not. It does remove source control bindings. Alright, to add the new project to our workspace, click here, add existing project, the new project, and there it is. And I'll set this as the startup project, and here's the file. Okay. Now last time I said I was going to talk about strings. I changed my mind on that. The reason will not be totally obvious to you, but I'm going to choose a different type of structure to look at. First in C world, and then in the new C++ world that we're about to introduce. And the struct that I've chosen to look at is one of the most basic structures of all, especially in Windows, the rectangle. Now I'm going to just, to avoid name conflicts, I'm going to just call this structure myRect, let's say, or maybe capitals, up to you, and give it a typical, this is the usual sort of definition. Let's see now, left first. I'm using ints for simplicity. That's the typical definition for a rectangle. There's a reason for this order, and the reason has to do with the fact that you can look at this as the union of 2 points. One, the top left point, and bottom right point. And points are always in XY order. So this goes X, Y, X, Y. Unimportant. Now what I'm going to do, and the step that I'll omit from the video, is I'm going to add a few functions to manipulate an object of this type. And then we'll see how that's done in C++. So this is just an example of something that we can handle in both cases, and look at what where the differences lie. So now I feel well, it will only be a split second for you, but a few minutes for me. I'll be right back. Okay, now here are some typical things that one might do with a rectangle. Move the rectangle from one position to another. Expand or shrink the rectangle by size in the X and Y direction. I'm assuming these are positive. They don't have to be. One might want to retrieve properties, the width and height, or find out where the top left position is, or the bottom right position. In terms of computer graphics, by the way, in case you don't know, top 0, 0 on the screen is here, where the cursor is. And over here is big number, big number. So X's are the same as you learned in high school, but Y's increase as you go down. So instead of a normal way in high school where increasing Y is going up. Now the first difference, this being a CPP file, not C, is that simply declaring a struct, as I have, automatically turns it into a type. This is immediately a type. So I can declare my rect without any keyword struct, like this. And it should compile. And it did. I can also, as in C, initialize this aggregate type, it's called at this point, with some values. How does it go again? Left top, let's say, and so 0, 0, that's over here, and the right, let's say, from the 100, the bottom 80. So that's a rectangle like that, from here to here. Two positions define a rectangle, 2 points I should say, or 4 coordinates. Okay, now to use one of these functions, I can just call it. Suppose I want to move, well, maybe I should print things out. Make it standard printout. So this will print out the contents of the rectangle. Left, top, right, bottom. Okay, and I want to be able to print this out every time I do something. So let's just run this as it is. It should give these 4 numbers in the same order. I don't know why it's over here. So there it is, 0, 0, 180. Oh, I know why that's there. I can fix that later. Okay, now I'm going to move the rect. So the move function takes a pointer to rect and either an amount in the x direction. Let's say I'll move it 40 in the x direction, and I'll move it 10 in the y direction. Hang on, before I do that, let me print the width and height. This is actually called R, not myRect. Height equals, I can use the function width equals so I can say width of our height. Now I don't need functions for these, obviously. I can just access the variables directly, but as you're going to see later on, with C++, we now have the ability to hide data from the programmer, and in particular, we're going to hide all these variables, but not yet. Let's see what we got so far. Okay, width 100, height 80, that's correct. Now moving the rectangle shouldn't have any effect. And in fact, we make this a function. Print rect info takes a constant myRect pointer to constant rect. Now I have to use arrows. And I have to use this name. There we go. I haven't done anything, but just put this into a function missing something. Syntax error bracket. Oh. Okay. Alright, so far so good. Now moving the rect should have no effect, at least on the width and height. So now the rectangle has moved, but the width and height are the same as we expected. Maybe I might shrink it. Let's shrink the width by 40. And the height by nothing. Now that the top left position should remain the same, the height and width, or at least the height should change. Okay, and so, okay, now there you go. Now we have a bunch of functions that operate on rects. I'm not doing any parameter validation. I'm not checking to see that I've shrunk it beyond its width. I'm not checking if the pointer is null or anything like that, because we're trying to just learn about the operations. In general, a finished product would take care of all that. Okay, the next step after this now is to look at this procedure at what we've done, what we've got here, in terms of the way you might approach it using the C++ language, and that involves change in our point of view, a type of paradigm shift, where what we're going to do is take these operations and bind them together with this structure in a way so that they become inseparable from each other. So that, again, is one of our goals in a better programming language, is the tighter binding code and data. So I would like to do that step in the next video. So now we've seen the C approach. In the next video, I'll start exactly from here and show you a C++ approach to the same problem. Okay, see you soon.